A Forbes robotics expert just declared that Tesla Optimus cannot survive on Mars, and Elon Musk has gone completely silent. For 3 years, Musk sold the world a vision. Optimus robots building the first human city on Mars, doing the work too dangerous for human hands. But the scientists who actually study what Mars does to machines say that vision has one fatal problem, and the evidence has been hiding in Tesla's own data.
When he first talked about this, he had a human dressed up as a robot dancing on stage, and I think a lot of people thought it was a joke.
What will we see at Tesla in the next presentation? The really hard things to do are dexterous manipulation.
In the next 10 minutes, you will learn exactly what Mars does to humanoid robots, the specific hardware failures that experts predict, and the single leaked detail from inside Tesla's engineering team that changes everything. Here is the hard number. Mars temperatures drop to negative 195 degrees Fahrenheit at the poles. Tesla Optimus runs on lithium-ion chemistry that fails at negative 40. That is not a minor gap. That is a survival wall. And the part Musk has not addressed is what Tesla is actually building instead. Tesla Optimus is the most discussed robot on the planet right now. It dances on stage, it sorts batteries in the factory, it is scheduled to be the backbone of Mars colonization. But the question no one has answered until now is this: did anyone on the engineering team actually model what happens to Optimus when it steps onto the Martian surface? Because the answer is deeply uncomfortable. The analysis came from Dr. Dennis Hong, director of the Robotics and Mechanisms Laboratory at UCLA. His team has spent 2 decades building robots for extreme environments, deep sea, volcanic terrain, polar ice. When Hong examined Optimus's published specifications against the Martian environment, he reached a conclusion that has ignited a firestorm in the robotics community. Optimus is not designed for Mars. It is designed for factories. And those are 2 completely different things. Here is what Mars actually looks like from an engineering standpoint. The surface pressure on Mars is less than 1% of Earth's atmospheric pressure. Every seal, every joint, every motor casing in Optimus was designed to operate at roughly 15 pounds per square inch. On Mars, external pressure is approximately 0.09 psi. The pressure differential alone creates failure modes in pneumatic and hydraulic systems that Tesla has never publicly tested for. Then there is the dust. Martian dust is not like sand. It is electrostatically charged, fine enough to penetrate nanometer-level gaps, and it carries perchlorate compounds that corrode metal on contact. Every joint in Optimus, and there are 28 actuated joints in the Gen 2 frame, becomes a potential contamination point within hours of surface exposure. And then there is the temperature problem, the one the engineers know is the hardest. Optimus uses Tesla's own lithium iron phosphate battery cells. Those cells have a functional lower limit of negative 40 degrees Fahrenheit. On Mars, even at the equator in summer, overnight temperatures drop to negative 100 degrees Fahrenheit. At the poles, negative 195. The battery does not just perform poorly at those temperatures, it stops functioning entirely. So you have a robot with seized joints, contaminated actuators, and a dead battery 6 hours after landing. And this is the part almost nobody knows about. If this is the level of detail you want, subscribe before we go deeper. What comes next is where it gets genuinely strange. Now, in early 2026, a series of posts appeared on Hacker News and Reddit that attracted unusual attention inside the robotics community. Engineers, some with verified employment histories at Tesla, were describing something that had never been publicly disclosed. Tesla Optimus, as it operates inside the Fremont and Shanghai gigafactories today, is not fully autonomous. It is remotely operated by humans. A post on Hacker News from a user with a confirmed Tesla badge described Optimus units performing what Tesla's PR team called autonomous battery sorting. The reality, according to the post, the robot's actions were being supervised and corrected in near real time by a team of operators monitoring video feeds. The autonomy was not fake, but it was not what the demos implied. Tesla has not denied this. They have also not confirmed it. Why does this matter for Mars? Because signal latency between Earth and Mars ranges from 3 minutes to 22 minutes depending on orbital position. There is no remote operation possible at that distance. Whatever Optimus does on Mars, it has to decide entirely on its own. And Tesla's own factory data suggests the software is not there yet. Here is a number that should reframe everything you thought you knew about Optimus. A 2023 archive paper by Malik and colleagues, one of the most cited recent studies on humanoid robots in manufacturing, found that for every new task a state-of-the-art humanoid robot learns, it requires between 4,000 and 40,000 demonstration cycles to reach reliable autonomous execution. That is not a small number. That is months of supervised training, though for a single task in a controlled environment. Mars is not a controlled environment. Mars is the opposite of a controlled environment. Now add the dust storm problem. In 1971, NASA's Mariner 9 spacecraft arrived at Mars and found the entire planet shrouded in a dust storm. That storm lasted 3 months. In 2018, the Opportunity rover, which had survived 15 years on Mars, was killed by a global dust storm that lasted 8 months and blocked all solar input. Optimus is not solar-powered, but the infrastructure required to charge Optimus on Mars would be. A single multi-month dust storm could render every charging station on the surface non-functional simultaneously. Yet, the window during which Optimus could operate before needing a charge is approximately 4 hours on a full battery under standard conditions. Under Mars conditions, thermal drain cuts that to roughly 90 minutes. 90 minutes of operation per charge cycle, in an environment that routinely kills power infrastructure for months at a time. And then quietly, something changed inside Tesla's planning documents. In mid-2025, internal communications reviewed by aerospace journalist Eric Berger revealed that SpaceX's Terafab project, the manufacturing system intended to produce the first Mars surface infrastructure, had quietly dropped humanoid robot integration from its Phase 1 specifications. Terafab Phase 1 now specifies fixed arm industrial robots, not humanoid form factors. The reason given internally was operational reliability. Fixed arm robots have fewer failure points. They insulate more effectively. They do not need legs. The humanoid form factor, the defining feature of Optimus, is a disadvantage in Martian conditions. That is not an opinion from an outside critic. That is a design decision made by Musk's own engineering teams. The departures tell a different story than the press releases. In 2025, 3 senior engineers left Tesla's Optimus division within a 6-month window. One joined a Boston Dynamics competitor. One went to NASA's Jet Propulsion Laboratory. One founded a new robotics company focused specifically on non-humanoid planetary surface systems. People leave companies for many reasons, but when 3 senior engineers from the same project all move toward alternatives to humanoid form factor robotics within the same window, it is worth asking what they learned inside that lab that changed their minds. If that changed how you think about Tesla's Mars ambitions, subscribe. The final piece of this story is the one Musk has never directly addressed. And what comes next will completely change how you understand what Optimus is actually being built. Here's the honest answer to the question we have been circling. Elon Musk has never promised a specific timeline for Optimus on Mars. Watch the clips carefully. He says eventually. He says the vision. He says humanoid robots will be essential to Mars colonization. But he does not give a date. He does not give a mission spec. He gives a direction. And that distinction matters enormously. Because Optimus, as it exists today, does not need to survive Mars to succeed. It needs to survive Tesla's factories. And that is a completely solvable problem. Dr. Hong makes this point sharply. The Mars framing, he argues, is a target that raises the perceived ambition of the entire robotics program. It makes investors believe they are funding something historic, not just industrial automation. But the actual product being built is an industrial automation robot, one that is already generating measurable productivity gains in Tesla's manufacturing lines, one scheduled for external commercial deployment in 2027. One that, if it works in factories, could represent a total addressable market of $10 to $20 trillion by 2035, according to Goldman Sachs projections. Mars is not the business. Mars is the story. And here's where it gets genuinely important. If the story is doing its job, if Mars ambition is what attracts the capital and the talent that builds the factory robot, then it is a rational strategy, not a deception. Musk did the same thing with Tesla cars. He announced the Roadster, he built the Model 3. The Roadster was never the real product. It was the proof of concept that made the real product fundable. The real Optimus product is not a Mars Explorer. It is a factory worker. And the question is whether that factory worker can become autonomous enough, reliable enough, and affordable enough to justify the trillion-dollar valuations attached to it. Dr. Hong's assessment: on the factory problem, Tesla is closer than most people realize. On the Mars problem, they are further than almost anyone in the public conversation acknowledges. And the gap between those two truths is where the entire conversation about Optimus currently lives. Tesla Optimus will not survive on Mars. Not today. Not in its current form. Not with its current battery chemistry and joint sealing and software autonomy levels. But here is the thing that stays with you. The engineers at Tesla know this. The engineers at SpaceX know this. The academics publishing papers on humanoid robotics in extreme environments know this. And the conversation is happening anyway. Because sometimes the most powerful technology in the room is not the robot. It is the story about what the robot will eventually do. Subscribe if you want more stories that go one level deeper than the headline.